So 3.4, we have Newton's law of motions. So we have three Newton's law. We go for the first one. We have Newton's first law. According to Newton's first law, is that if there is no net force acting on an object, the object that is at rest, it will remain at rest, or if the object is moving, then it will continue to move in a straight line with constant velocity. So the net force here actually is referred to the resultant force, means the summations of all the forces acting on that particular object. So Newton's first law will give the ideas of inertia, whereby we define inertia as the tendency of an object to resist changes in motion, and basically inertia depends on mass. So recall our prior knowledge, mass is different from weight. Mass will always be the same. Anyhow, our weight will depend on the value of gravity. For example, 1 kg of object will if we put it on moon, it will weigh only 1/6 as much as it did on Earth. So basically, a bigger mass will need a bigger force to overcome its inertia and change its motion. So the Newton's first law will bring us to what we call equilibriums of particles. So a particle is said to be in equilibriums when the vector summations of all the forces acting on that particular particle or object is equal to 0. So if we write it in mathematics, it means that the summation of forces is equal to 0. Then class, we understood that force is a vector quantity. So normally, it is easier to work with the equation in terms of the components, whereby we always know that we can break up our vector into x and y component. So we might have summation of force in the x component or x direction equal to 0, and summation of force for y component or y directions is equal to 0. So basically, there are two types of equilibrium for particles. First one, we might have what we call static equilibrium. So what is meant by static equilibrium? Static equilibrium means the object will at rest, stationary. So the velocity will become 0. Second one is what we call dynamic equilibriums. So what is meant by dynamic equilibriums? Dynamic equilibriums means body will moving at uniform or constant velocity. So we understood that constant velocity means our acceleration equal to 0. So how I'm going to know that for that particular situations, we are going to apply Newton's first law, or at that particular situation, we satisfy Newton's first law. So always find for these keywords: constant V, at rest, in equilibrium, static, at the verge of motion, just begin to slide, static equilibrium, dynamic equilibrium, all forces acting are balanced. So all these keywords were telling us that that object satisfied Newton's first law. Then we move on to Newton's second law. According to Newton's second law, the rate of change of momentum of a moving body is proportional to the net force, and it is in the same direction as the net force acting on it. It can be represented by summation force is directly proportional to rate of change of momentum dp over dt. Then you might wondering, last time during school, my teacher said Newton's second law is summation force equal to ma. So let us see how we can get this equation summation force equal to ma from the definitions of Newton's second law. Here we go. So according to Newton's second law, we have summation force equal to the rate of change of momentum. Momentum is mass multiplied velocity. So we might have summation force is V, rate of change of mass, plus with mass multiplied the rate of change of velocity. Anyhow, for most of our situations, our mass is constant. So the rate of change of mass is equal to 0. Therefore, we will have summation force equal to m rate of change multiplied with the rate of change of velocity. Then we understood that rate of change of velocity is referred to acceleration. That's why we have this equation in Newton's second law, summation force equal to ma. So the summation force is referred to the net force or the resultant force for the object. M is referred to the mass of the object. A is referred to the acceleration experienced by the object due to the net force. So rearrange the equation. We are going to have acceleration is summation force over m. So we can see very obviously from the equations, the accelerations of an object is directly proportional to the net force acting on it and inversely proportional to the mass. So since force is a vector quantity, so the direction of net force is always same as the direction for acceleration. So for example, for this car, there is a 10 Newton acting rightward and 7 Newton acting leftward. So the net force will be 10 minus 7 equal to 3 Newton. So this 3 Newton will contribute to the acceleration of the car, and the car will be accelerate towards right as well. So this is what we mean by the direction of acceleration is same as the direction of net force. So what is the keyword in order to implies that the object or the system is satisfied Newton's second law? So here is the keywords: accelerate, unbalanced forces, resultant, or net force acting. So these keywords were telling us that our system satisfied Newton's second law. Here is the tips for you to write out Newton's second equations correctly. First, try to identify the direction of acceleration. Then, we are going to treat the direction of acceleration as positive. So, we are going to take the forces in the direction of accelerations minus the forces that are opposite to the acceleration, then equating it to ma. So, how we define 1 Newton? So 1 Newton will be defined as the amount of net force that will give an acceleration of 1 meter per second squared to an object with a mass of 1 kilogram. Then we move on to the last Newton's law, Newton's third law. According to Newton's third law, every action force has a reaction force that is equal in magnitude but opposite in directions. So when you push on the wall, actually the wall will push back with the same forces. So the hand that applies force on the wall, FAB, is considered as the action force. And at the same time, the wall will push back with the same amount of forces, FBA. So this FBA is what we call reaction force. Sometimes the FBA is also known as normal force. So for example, for this situation, when a book is placed on the horizontal table, the weight will acting downwards. So the weight of the book that press on the surface of the table is what we call action force. Then the table will apply a normal reaction force that try to push the book away from the surface of the table. So this normal force is what we call reaction force. So this action and reaction, which is equal in magnitude but act in opposite direction, is what we call Newton's third law. Then class, please take note, the action and reaction force is actually act on different body. So they will not be cancelled out each other. So from the diagram, you can see very obviously, the action and reaction force is acting on different body. For example, this action force is acting on the desk and the reaction force is acting on the hand. Okay, so they will not cancel out each other. So here is the problem solving strategy on how to apply Newton's law. First, normally we will draw out the free body diagram that show all the forces that are acting on the object. Second one, we are going to choose the axis, which is x direction and y directions. Then for any object that we place on inclined plane, we will treat the inclined plane as our x component or x directions. Then what we should do is we need to resolve or break all our forces into the x and y components. Then only we apply our Newton's law of motion for component x and component y separately. So you might try to attempt question 15 to questions 26 in your tutorial 3 on how to apply the Newton's law.